Let's take a look at the strange subject of addresses vis-a-vis lists of lists. So here I have x and it's equal to, let's say, 8, 9, a list within a list. And now I've got this. But what if I take x and make it equal to x times 4? Now what's an x? Whoa, I've got 4 of these guys. All within one list, of course. Now, what's the length of this list? The length of x is assigned to b, and what's in b? Well, 4. 1, 2, 3, 4. Or 0, 1, 2, 3. Now, I'd like to see a listing out of all the addresses that these guys point to in memory. We're going to see that they're actually the same. For A in range B, do the following. I want to see the ID of X, element A. Now, what this is saying is the following. I want you to go through, I want you to do something, range B, 4 times. For A, in the range of 0 to 4, oops, not up to, but not including 4, so that's 0, 1, 2, 3. Give me the ID of x0, then x1, then x2, then x3. And it stops just before 4. All right, let's see what happens now. And there we go. Oh, they're all pointing to the same address. How can that possibly be? So here is x, and here are its 0, 1, 2, and 3 elements. Every single one of these guys are pointing to the same area of memory wherein 8 and 9 reside. And that is why they all have the same ID, the same address. They're all pointing to the same guy. So if I now make the mistake of keying in x, oops, let me click in this area. Let's take a look at what is in x. I want to change the 0, 1, 2th guy right here. So I'm going to make the mistake of keying in the following. X, your 2th element, and its 1th element, not the 0th, but 1th element. So x, 0, 1, 2, your 2th element, which consists of a 0 and 1 part. I'm looking at the 1 part right there. That guy right there is now going to be equal to 5. Now I hit enter. What did I just do? What I just did was I went down to here, to where the 0, 1, 2th element's 1th element was pointing to the 9. And what I just did was I erased the 9 completely, and I replaced that with a 5. So now every single one of these guys are now pointing to 8, 5. No, that can't be, you say. Well then, let's put it to the test. I key in x and enter. They're all going to say 8, 5. And they do. Wow. But now I just want to change one of these guys, the second guy, 0, 1, 2, the 2th element. I want to change that to 1, 2. How do I do that without affecting the others? This is how you do it. You key in the following. X, yes. Your 2th element, yes. At 8, 5, yes. The 2th element, the one that's pointing to 8, 5. I want you to change the 2th element so that it is pointing to something else, a different array, a different list, 1, 2. And I hit enter. Now when I key in X, dollars to donuts, everything is 8, 5 except the 2th element, which will be 1, 2. And bada bing, bada bang, bada boom, it worked. Now if I key in for A in range B, that's 4 elements. This translates to 4. Show me the ID of X, the 8th element. So it's going to go through each one of these guys one at a time and tell you what address they're pointing to. Dollars to donuts, these 1, 2, and these 3 are the same, but this guy's going to be different. This guy's going to be pointing to a different address. Here we go. And 37057 880 Wow, number 2, the 2th element is different. 3th element is the same as the 1th and 2th. This guy's different. What do you know? And doesn't it make sense? This has to be pointing to something other than what these guys are pointing to. So graphically, what we just did is we removed the 2th element from pointing to this guy, and now the 2th element is pointing to this area of memory over here, where the value 1, 2 resides in a list, like so. The 2th element is pointing to address 3705680, while the other 3, 0, 1, and 3th elements are pointing to 370578880. These guys are different addresses, as is evident here. This is George Boole. I hope this was helpful. Please rate and share this video. I'd appreciate that. Good luck.